And so I'm looking very much forward to hear from him about C++ in the developing world and why it matters. Matthew himself comes from Kenya, so he kind of knows what he's talking about. And so, Matthew, let's get started.
Okay, so hello everyone. My name is Mathew Benson. I'm from Nairobi, Kenya. And I'll be speaking a little bit about C++, which I really like. And I would like to believe that we're all here because it's a language that we like. And I know maybe some of us may be new to the language and you're here because you're curious. So we're mostly here to talk about this language, why this particular language I think holds great potential. And this is coming from my work and my experience with programming. I am a computer scientist by trade. So I've been working with computers for a very long time, practicing and programming and tinkering, trying to make it work, especially in situations that are not what we're kind of like calling the developing world. So it's something that I've been working on, trying to find ways to make computing work in unusual areas and places. I'm particularly passionate about energy efficient computing, making the most out of older hardware. And I mean, this is connected with what I'd said earlier. So you can reach me. Twitter, I'm at Benson Orina. On Mastodon, you can find me on email at benson.orina@live.com. I have a GitHub page, Mathew Benson Code. And I usually hang out at the CPP Africa Discord server. So what will we be talking about today? The three main areas I will touch on today. First being the importance of C++ as a language when we are writing efficient code for older hardware, which is much easier to access in the developing world. I'll also look at C++ as a language for learning about software development and why I think it's a very important language, especially because of its connection with C. But I'll get more into that as we go along. I'll also touch briefly on some tooling and resources, especially in unusual circumstances, places where you're constrained by resources. Some of my experience in this and what I think may be a good way forward. So to begin with, I'd like to define a few terms. The first and most important term I'll define is the first word in the title of this talk, C++. What exactly is C++? And I know this is something a bit strange. It's not a usual question that you'd expect to be asked here and at meeting C++ or at a C++ conference. But it's actually an interesting question because I try to think about it in terms of how do I explain this to somebody who doesn't know exactly what it is. And it's actually a difficult question to answer without first talking about C. Yes, it is a programming language, but C is the very first character in its name. So many of us do know, and those who do not know, that C++ is an evolution from an older language called C. And this evolution is analogous to a journey. And C, in times past, was referred to as a high-level language, meaning it's higher than something. And that something is the machine language. So when we program, we're talking about translating concepts that are written in a more human-like way to a language that our computers understand. So as computers have advanced, the machine language used to be programmed manually with, circuits and other means over time. And as complexity increased, there needed to be a way to describe more complex features and functionality and programs. And many programs have been written, especially in C, over time. But as complexity did increase, as we tend to deal with more, as our hardware has gotten faster, problems that we are solving are more complicated, we have needed to step up from C to express things in a way that is easier to manage the complexity. So C++ was a step up from C. And even C++ itself has really grown. It started, as many of you know, as a project called C with classes. And it grew, got a new name, C++. Then eventually it got standardized, the first standardization in 1998. And there have been many standards. There's ISO group, which keeps on releasing new versions over time. So this particular language has a very beautiful attribute to it, which is basically one of the things I really want to emphasize in this talk. And in dealing with that, one of the most important things in this language is the plus plus, C++. Many of you will know that there is an incrementing operator, which basically means add by one. Take a single step. So the way I see C++ is that it is a language that has been taking a single step at a time, managing the complexity up until where it has reached today. And that step-by-step bit is actually one of the reasons I think it is a very important language. So I'll move on to talk about the developing world. This is the next important phrase in the title, C++ in the developing world. Wikipedia defines the developing world from the perspective of income levels and access to money. And yes, it is a fact that we are all aware of, that the different countries, different places with different access to resources and jobs and income and the like. I'll take a slightly different trajectory in this talk and approach it from the perspective of computing, because you see there are many other aspects, but we'll focus in on programming and computing and access to computers and what computers can do for us. So in order to do that, in order to define developing, well, we must first talk about what it means to be developed. What is this development? What does it mean to be developed? So developed computing, ideally, we're talking about an ideal state, that you have a computer that is fast enough to do everything you need it to do. Whatever you throw at it, it does in good time, great speed, multiple tasks, and the like. It also means having access to other people through your computer, connectivity, internet access that doesn't feel slow. And to power all this, you do need electricity, a constant supply of electricity. And just as a small aside, that yes, you can have access to the internet, but having it consistently and persistently is what I would describe as that's a developed experience. That's something we yearn for and we are longing for. And a very important thing that is very easy to overlook is a knowledge to know what to do with these resources, knowing how to harness it. And very importantly, especially in the discussion when we're talking about developing or developed world or developed computing, is for many people to be able to access it. It should be at a friendly cost to as many people as possible. So now that we've touched on what it means to be developed, the word developing in the phrase developed world is, we're talking about a process. We're heading there. We are working towards that ideal state. But we're not at there. We are lacking in one of the in one of the developed states, so to speak. So in terms of computers, if the word developing, I'm describing the word developing as lacking in one of those areas. For example, yes, I could have electricity, but I have no connectivity. Or I may have connectivity, but I have no power or limited access to power. Like my laptop would go off in an hour's time. How much can I actually do in that time? So, world, the word world, as in developing world, I want to emphasize that for the context of this talk, and I think being fair to just any individual, just taking a blank canvas and saying we're talking about just anybody who is in any situation where they're lacking any of the ideal states, so to speak. So the developing world is just any place that is not at that perfect state of computing, be it cost-wise, power-wise, knowledge-wise, and the like. So, in light of that, I'd like to speak a little bit about older hardware. And in light of that, we do know that as time has progressed, one of the things that has changed is that our computers have gotten smaller and smaller because the electrical components that make up our computers are getting smaller and smaller. That we have, like, what would be a computer that would fill a room in the 1970s or 60s fits even within our phones. It fits in our pockets, like a phone fitting in our pocket, or even our watches. Our smartwatches actually have so much computing power. But this advancement changes things in interesting ways. One of the benefits of smaller components is that they use less power. And when now you're using less power, you can either make things smaller, but maintain the same level of computing, or you can do a lot more with the same amount of power. For example, at a certain power budget, say 100 watts. These days we have 12 cores, 8 cores. When a few years back, that was just 2 cores, or even just a single core. So older hardware usually means that you have access to less resources. That if you are using a computer from 10 years ago, for the same amount of energy, you likely have less cores, or for the same amount of cores, you'll be using a lot more energy. And the fact of the matter is that new hardware is expensive because it takes a lot of money to make these small, tiny hardwares, to put so many CPU cores within a small area. So one of the good things is that as technology advances, the older hardware becomes cheaper, meaning that it becomes easier to access for more people. So the title of this talk is C++ in the developing world. And C++ is a language with performance at its heart. So I want to transition that now to talk about why efficient code matters, because it helps to bring down the cost of computing. That the better code we write, the more access it provides to more people. And there is a very large population of people that may not have access to the resources that would allow them to have that ideal computing environment. So it is with code that we can bridge that gap, in my opinion. So this is the cause that I think that we as a C++ community should be targeting. Yes, there is a performance goal, which is good, but the purpose of even this talk was to bring out the conversation that where does C++ matter? It matters in the performance that reduces the cost of accessing computing in the world. So there is a riddle of how do you balance the cost of computing, the quality of computing, and the cost of computing. And naturally, things have taken an interesting, shall I say, progression. Because on the angle of computers becoming smaller, I do see in my country that these days, almost everyone you meet on the street has access to a smartphone, meaning that that is the computer they have access to. But does our code meet the needs of computing? I mean, can a mobile phone do what a PC 10 years ago could do? Another thing a trend that I have noticed is that on the streets, on the high street and in the marketplace, there's a lot of, shall I say, older and obsolete computers from developed countries, former office PCs. These are the PCs that people are now having more access to. However, they were discarded because they probably use too much energy. And that in itself is a problem, because now there are computers, but how do you make them use less energy so that they're able to be used in more places than, and especially like in places where outside of cities, in rural areas, how do we bridge that gap? And it is indeed true that we do see, shall I say, new computers, new budget computers with our manufacturers. But more often than not, it tends to be that these new computers are just older hardware, given a new name, repolished, so to speak. So there's a riddle of how do we balance all of this? How do we bridge this gap? Just as an aside, I'm aware that Chromebooks are regarded as a low-cost computing platform. However, Chromebooks do have a problem because they require you to be connected. So even if the hardware or like what Chromebooks are, you see, it's essentially just a Chrome browser tied to the to a Linux system, but it's closed down. that you really can't, hand somebody a computer and they go off to the mountains and they're able to compute, because it's designed to be used in a connected environment. So this what is regarded as a budget computing experience in a country where there is good internet connectivity might not work in the rest of the developing world. Mobile phones, on the other hand, do hold some potential, because I do see that mobile phones are accepted by many more people. Many people have them and many people are using them. So they do hold some potential if the software is able to bridge that gap of the ability to use the phone itself without the network connectivity. So the power of software to solve this riddle. A fact is that in the developing world, the computing systems available to most people would usually be underpowered or very inefficient, so to speak. Therefore, software performance is crucial, because it is very important to always think about this low end, because this performance is where the people that need it the most are. This is where the efforts that we make with our language, making our loops more efficient, making every optimization, this is where I think it really matters. It's also a place where scale matters, because large deployments, say schools, governments, in any attempt to roll out computing education to a large number of people, the projects that wouldn't even take off because the cost is just too much. But if the cost is lowered, if there was a way to do it, then more people would be able to benefit from it. So I just wanted to touch briefly on the evolution of software. I've talked about the evolution of hardware, that yes, it has gotten smaller. But there's something very important that also happens. Our software has also been evolving. What C++ is now is not what C++ was 10 years ago. So this evolution is also bringing new opportunities that would bridge this gap. There are optimizations that come up after the hardware is in people's hands. As people work with it, people find new ways of writing better software that, if applied to the older hardware, would be very beneficial. And one of the areas that, in fact, I'm really looking forward to with this regard is the use of the C++20 modules. Something I've been experimenting with a little bit, and it couldn't come sooner, because it reduces so much work, unnecessary work. Pound include needs to go. We need to use the import statement. So I'd like to speak about why I think C++ in particular is very important in solving this problem. One of the core things about it is its design. It's designed with awareness of the cost of doing things. It is a very realistic language, in my opinion. It's not designed to hide from you what is actually going on behind the scenes. So we need to be mindful of every cycle, of everything that our programs are doing. And that control is available to us in C++ by design. it gives you control over the stack. And having control over what our programs are doing, having control and knowing that what you're doing costs this much, but this is the benefit I'm getting from it. Having that control is very crucial, especially in areas where the cost of ignoring wasted cycles really matters. I know I have worked with, for example, C# before and Java. And I know some of you do know that there's this approach by the governments of, I think, America and Canada and like many nations, talking about security, secure safety, memory safety, saying that C or C++ are unsafe languages. So they're pushing to the quote-unquote safe languages. Well, there's been quite a bit of discussion about this. I think I've seen a couple talks this year about these developments. But I still do think that C++, in particular, it's like fire. You know, it's dangerous, but it's also useful. And its performance is very essential, especially where the cost of computing is very sensitive. So we're discussing about the developing world. So I guess the concerns of the developing world might be a bit different. Our focus is in performance, in lowering the cost. Safety may not be an issue, but still C++ is an improvement on C that brings that safety to the masses, so to speak. One of the areas I think C++ also shines, in my opinion, is with the compile time computing. This is something that's been worked on and has been built into the language. Const expr, we want to compute as much as possible at compile time so that when we deploy our software, it doesn't waste time doing unnecessary things. So the less work done on the client PC, the better for energy and accessibility and cost. So there was a talk called C++ Seasoning by Sean Parent, which he gave some time back. And there's a section of that talk where he talks about structuring of code, especially for parallel computing, that you need to be able to structure. If you structure your code right, then you can be able to take advantage of the parallelism that is available to us with our many cores and our many threads in this day and age. But it requires structuring your code right. And that needs access to the stack. That needs control. You need the tools to control and to write your code well. That's something that I feel C++ does give us. So one of the core things, or one of the core points even that I want to make even in this talk is that C++, the evolutionary nature of it, is actually one of the core benefits of it. So I believe most of us have heard of the mantra of, rewrite it in Rust. Whatever problem you're facing with C, just rewrite it in Rust. But I propose that it's better to use C++. And the reason why I say that is that I think that as we write our code, as humans, our evolution is step by step. The way I used to write code 10 years ago. It's not the way I write code now. And you notice that even in large code bases, code changes gradually. You might start out using camel case, and at some point later on, you change and say that no, we're going to name our variables snake case. The point is, whatever improvements we make are generally step by step. And that's what I think C++ represents, that step by step nature. That you literally see the growth, even in our own code or in a code base in a company. You see that things have been improving over time. And it's likely that, like many of us find ourselves in a situation where we have code that has been written a certain way, C++ 98 style, and changed to maybe C++ 11 over time. Yes, that can be a problem, but also I think it also offers an opportunity for lifting up those old code bases with something that's compatible, because you can get to change just one function at a time, or like a small library, you can rewrite it using modern ways and still maintain that compatibility. And I think that's how software likely does grow and improve. So the compatibility with C, especially with so many libraries written in C. Actually, the other day, I think just like a day ago, I saw a blog post by the author of the CURL library. I mean, he was talking about evolving the code, the mistakes that have been made, the errors that have been made. And as I was reading that, I was looking at his, he did mention why he wouldn't rewrite the code in Rust. But as I was reading that, I was thinking about that there is an opportunity to lift up our old C code bases, a function at a time, a loop at a time, by being able to introduce C++. So I think that this language does have that potential to lift up code bases that we're using now that are written in C, but can be modernized step by step. So the other thing is, just in the same vein, that a lot of what we actually use today are libraries that are close to the hardware. And they're written in C, OpenGL, Vulkan, Direct3D. But to be able to add more complexity, or to like, the reason why even many of our games are written in C++ is because of the compatibility. So this language gives us access to a lot of programs or a lot of libraries that are still in use today. It's kind of like an international language of computing, but with benefits of safety, benefits of modernity. So I do think that this compatibility, that C++ may be the best way to lift up our code. Of course, it may mean going back and rewriting that code, which I know is a significant cost, but I think it's important to discuss and to consider. So in light of that, now that we've talked about the why C++ is important, I'd like to touch a little bit on the how. How do we make this happen? Well, I'd like to give a disclaimer that I'm not a teacher. I'm just somebody who happens to have spent a bit of time with it. So I'll just give a few thoughts on what I think about learning this language, about my thoughts on how I think it can be done. So I'll not rely so much on statistics and facts and figures, but I'll just speak on my own experience. And hopefully, even as we discuss this more later, maybe people will share what I'm, what my thoughts, so to speak. We are conversant with the concept of our diversity, that we are very different. There are many different kinds of people, different kinds of circumstances, different talents, different abilities, and what have you. So, but there are also those things that are common to us. So I'll approach this from the perspective of human language, comparing it to human language, because C++ is just a language. So let's compare with how we learn our human languages. So there is a website for the American Linguistic Association, and there's an FAQ section in that website, which I find very interesting. It talks about the process of how children learn how to talk, how we all develop learning how to talk. It states that we have the natural ability to pick up language, just like a bird has a natural ability to fly. So the primary way that we get to learn how to speak is based on the interaction with the language, talking with adults, talking with other people, just speaking, using the language. That's how we learn the language. And the steps of learning the language are pretty similar, regardless of the language. I'll not go into the steps right now, but you can have a look at that site. It's a very interesting read. But the core thing is that this learning is gradual, and there are steps involved to it. And one of the core elements of learning language is that the parents and those around a child have a very crucial role in teaching the language, because it usually comes by interaction. So we can help people learn this language, of course, by talking about it more, by sharing what we've written, the same way that children get helped to learn the language by their parents. Sort of like taking a step down. As a parent, usually, or those who are around a child, you usually use baby talk. You kind of like step down a level, and you help the child to come up to where you are. So the same mantra, I think, has potential in teaching this language called C++. So the point is that in order to do this, we need to do it together. The human interaction is the key to making it possible for more people to understand this language and to understand how to use their computers, or how to make the most out of them. Because as I mentioned earlier, that the knowledge of even what to do with your computer is actually very crucial. If you don't know, then you'll likely be using it in a very wasteful way. But if you learn, if you're able to speak, if you're able to read and understand more about what the computer is actually doing, then there are more opportunities for optimization. So this is the benefit of these meetups, of our conferences, our user groups, our Discord servers, etc. So the more we speak about code, interact with our code, read it, the better we get at using our computers. So we also need to constantly reevaluate why we're using our computers, why we're doing what we're doing. And we need to, shall I say, be like the ambassadors. Because we are the developers. Our families look to us, people look to us to know what to do. So how we to do this? I'm looking for ideas, but this is just my thoughts, because we are all very different. So we all have different starting points. So for example, what I may think is the best way may not be the best way for everyone. But hopefully, as we just try and reach out, we'll be able to help each other. So in light of that, I'll give my opinion on what I think is a roadmap for learning C++. Because just as I alluded to earlier, with our diversity, there's no one size fits all answer. But there is the concept of seeking and finding, because you need to really look for the people who understand things the way you understand things, or people who may be able to explain things to you in a language you may understand. I say this because I've had, from many people, saying that, oh, how did you learn? I feel discouraged. I may not be able to learn. I don't think I can do it, or I don't think I can understand the way you're telling me. But from my experience, I have learned from many people. I've had to learn and relearn. Actually, there was a time there that I actually wasn't quite sure if the problem was with me. Like, kind of like, why am I not understanding this? But I've learned that you learn different things from different people. I might be good at explaining this concept, but somebody else is better at explaining something else. So you do need to just keep at it and find that explanation that matches the way your brain works. And so we need to see the story, the C++ story. But to see the story, we need to talk about C. We need to be aware that there is a history to this. When I gave this talk and CPPCon, somebody thought that I meant that there's no way of learning C++ without learning C. Yes, it is possible to learn C++, but I think to make the most of it, you need to be aware of where things are coming from. For example, when you use a stud vector, you need to be aware that, yes, stud vector is an improvement of the classic C array. And you need to understand, it's good to be mindful to understand why vector exists, why string exists, as opposed to const char stars. So as you use a language like C++, the name C is in its structure, meaning it's an improvement of something. That even though you use modern C++, it's always good to be aware that there's more to it and dig into it. Find out, when you have the chance, why was it designed this way? Because it has taken a lot of work to get here. It has taken a lot of effort to grow step by step up until where we are. And the beauty of C++, I think, in my personal opinion, is best appreciated when you see where things are coming from. Just like a movie in a series of movies, it's a story that's very rich, that may not be able to fit to the length of one movie, but it's like 10 movies worth, of a lot of effort to get here. So as you use the modern features, when you have the chance, just take the time to dig a little deeper, because that's where the beauty of C++ actually does lie. Because I think personally that there is a great opportunity to revisit old code, even just, like the many repositories, and just try and lift up a C code base. Try and use an iterator instead of pointers and see why iterators exist. Like, these are things to do, especially for those that are wondering, where can I get a project to to show off what I can do. It's these small things. Lift up a C function, write it in C++, and see where things were and where things are and where things are going. So, the one step at a time is what I think is the essence of C++. Plus one, plus one, plus one. Because in the words of Lao Tzu, a journey of 1,000 miles begins with a single step. So it takes time to learn, especially for those learning now. It does take time, but it is possible. So it's just something that you just need to do. You just need to take one step at a time. Keep your map at hand. For example, there's a cppreference.com site. Like, keep it as close as possible to you and just take one step at a time. You will get there. Don't be discouraged, just keep at it, because even this language has taken a long time to get to where it is now. So I just wanted to mention, just as a foundation for those who are trying to learn, that you need to understand the structure of the language. That yes, even if you may be able to copy and paste code here and there and read from the internet and what have you, it's very important to understand these concepts. It's very important to go back and just really understand what these concepts mean, these foundational concepts, because they'll help you to see the whole picture. So I want to touch briefly about tooling, especially in resource-constrained environments, especially when it comes to learning about programming, learning about computers, learning about C++. When we're dealing with older hardware, we have less luxury, so to speak, to have certain niceties. And it's very important to be mindful of this. But then again, also, it's very important to know and to see that it's very important to walk. I mean, to learn to crawl before you walk, and to walk before you run. So even if you're working with constrained hardware, even if you don't have as much energy, even if your computer is slower, in a way, it's actually to your advantage, because when you're starting out, you kind of like need to start slow. So being slower is not a problem, but it's something to keep in mind. So when we're talking about spreading computing, learning computing, you really don't have to have the latest and greatest hardware, because the concepts that you're dealing with are pretty simple. So take your time, and it's okay to start a bit slower. And in regard to that, one core thing that would bridge the gap is looking to how things were done in the past. So in light of that, when one is learning computing, I would advise, this is my personal advice, if you are working in a constrained environment, don't start with the integrated development environments. They are too heavy on older computers. They're designed for high-speed work environments when you have the luxury of having fast hardware to run them. So I think, as a way of bridging even the cost gap, that when we're talking about teaching, we can take a step back and start with a simple terminal, with just the compiler. Like, how do you give the instructions to the compiler. Then once you're comfortable with that, then now you can graduate to the IDEs. Because the IDEs make those processes faster, but you need to understand what the computer is doing for you. You need to understand what an include file is. What does pound include actually do? And why are we now being told to use import? When you're using an older computer and a slower computer is when you really, really understand the difference. So it's useful to step back to the terminal, to how things used to be, especially when dealing with programming. This is where we are coming from. This is how things were done in the 80s. This was the state of the art then. It used to run on what was the high-end computing then, but what is very cheap now. And starting from this foundation, I think will give you a better leg up in understanding these complex things that you hear about in programming. It'll help you to understand what is actually going on. And it's also a very low-cost model for teaching programming to more people in more situations, because it allows us to do something very interesting. It allows us to make more use of a single computer. It allows us to find opportunities for more people to use the same hardware if it's harnessed in the correct way. So in light of that, I would urge anybody trying to learn programming to really take the time to learn about the terminal, to learn about shell languages, learn a bit of Bash, a bit of PowerShell. Just Google them and understand what they are. That is a very core starting point. Then, as a next step, there's the importance of keeping as much as you can locally. This kind of like deals with the issue of connectivity. That it's important to have as much as you can, as close to you as you can, so that you're able to chew on it, work with it, feel it, know it, live it. Like if you're learning to speak the language C++, you need to be exposed to it, you need to be working with it, you need to be, it needs to be like air to you. So keep the resources as close as you can. Buy a book, hold on to it, carry it with you everywhere you go. There is a way to download the entire cppreference.com site locally. I use Arch Linux, and it's available as a package there on Arch-based distros. There is a way to download even there's a very good documentation on the Microsoft website, the C++ section. It's even downloadable as a PDF. Put it on your phone, print it, carry it with you everywhere you can. It's actually something I did some time back, and it was very helpful to me. And buy good books when you can afford to. So, in light of that, just along the same vein, so to speak, it's always important to keep as much as you can, as close to you as you can. For example, having access to Compiler Explorer on a local LAN, say in a school, is useful because now you don't have to worry so much about the cost of always connecting to Amazon. So even if you're in an isolated place, a small group of people can be able to, write code, churn out code, practice. The point is, keep it as close to you as possible. Practice, practice, practice. It's invaluable. And another benefit of the terminal, so to speak, like I'd mentioned earlier, is that it allows multiplying computing resources. And there's an opportunity here, especially with the prevalence of mobile phones, that mobile phones can run terminals, the terminal emulator, so to speak. So it's possible to share even one computer amongst many people using mobile phones as the low-cost terminals, but sharing one, kind of like desktop PC as a means to practice and rehearse and work with the computing. So it's actually something that I do. I generally always SSH into my wife's Windows PC, but generally I'm on Linux. And I'm always, even if she's using the PC, I'm able to, kind of like share the resource, because all I just need is a compiler. And I use Vim, so I'm able to do everything I need to do. Windows, Linux, just at the touch of a button. And I think there's potential here for multiplying what one computer can do and reducing the cost of just general computing. So, in conclusion, I think C++ has great potential in lowering the cost of computing. I think it's the language to learn because it is, shall I say, the most profitable language in my opinion, especially because of the access to C-level APIs with a common language. And these performance benefits of writing code well, I think is the way or our way of making computing more available to more people, especially with the prevalence of older hardware that's being discarded. So we can reduce on the e-waste. We can make more use of what is being thrown out in more places. If you can reduce how much energy tasks take, then it means connecting a battery to a desktop and having it, kind of like connected to a Wi-Fi network is something that can bring more opportunities to more people. So these are my thoughts on why I think C++ is important. And I think we can do a lot more with our computers. We can reach a lot more people. This is kind of like just a message that I felt my heart to talk about. And hopefully somebody out there sees the same as me. So I think that this language is something that we need to keep alive, needs to be taught more, it needs to spread more. Yes. So thank you for your time. Thank you for taking the time to be here and to listen to this talk. And I hope that, this will start a bigger conversation. That's my dream. That's what I hope all this leads to. So thank you very much. That is my talk.
Thank you, Matthew. That was an interesting talk. There's some more general questions which we have. I might, favor taking some of those to the panel, but let's just quick do those. Let me show them here. So what are your thoughts about premature optimization? Do you think software engineers following the statement premature optimization is the root of all evil in the right sense?
Well, I think, yes, it is possible to, kind of like waste a lot of time, trying to optimize for the wrong reasons. I think, okay, generally, like what, when I'm writing code or when I'm working on programs, I think if you use the right structures that have been, researched on, say, using vector, just, there's a common advice, like just use std vector. It's something that is already established. That's a good starting point. Then only optimize after I mean, kind of like you have something off the ground. So yes, premature optimization is a trap that many people do fall into. I would advocate more for kind of like just start with a standard established structure. Kind of like use the algorithms, the stood algorithms, and only optimize after you kind of like have something on the ground.
Okay. Someone like wonders like, how do you see like a general feeling about variable naming, especially like in the context of like code being like read internationally?
I think something that even I personally struggle with is kind of like coming up with a consistent naming convention. Sometimes when I'm starting out, I start with this convention, and maybe like maybe a few months later, I start naming things differently. I think that the ability to go back and change things or to adapt things is, I mean, like in your projects, it's important to be open to going back and changing things. So variable naming, I mean, if you're accommodating somebody whose language is different from yours, it's something that needs a bit of time and care, so to speak. I mean, it's all about who will be reading your code and why will they be reading your code. So, I mean, if your audience is, say, primarily, say, French, for example, and you see like the purpose of naming things, naming functions, naming variables is that it's supposed to be readable. So I would imagine that even if it means having different versions of your code base to ensure that as many people are able to read it as possible. I mean, the goal is to communicate. So, I mean, it depends on your audience. It depends on your team, so to speak. And I think we shouldn't be afraid to go back, and even if it means renaming everything, just to accommodate, I mean, to accomplish that goal of clear communication. Like your code should be readable at the end of the day. That's what I think.
All right. Then let's continue with the panel in 10 minutes. And
Okay.
thank you for your talk. And we'll see us all in 10 minutes at the panel.